Hello guys, I hope everyone are doing good. My name is Likita Dakupati. Currently, I'm pursuing my master's degree in the University of Houston, Victoria. Yeah, and my major is in computer information systems. And finally, this is my last semester, which I'm going to graduate this spring. And today, I'm going to discuss a topic on visualizing COVID-19 data. Here, moving to the agenda, here these are the topics we're going to discuss on this project. Objective, the main objective of visualizing COVID-19, some of the steps involved during the process of visualization, data collection, data cleaning and pre-processing, data transformation, data visualization, and visualization development. Data visualization using Python, and program and output, where we run the source code and we'll see the results like chart, and after that findings and insights, finally takeaways and conclusion. Objective, coming to the objective, the main objective of this visualization COVID-19 data is to analyze and sorry the main objective of this is to analyze and present the data related to the COVID-19 pandemic in the United States using visual representations. In visualizing COVID-19 data project, it involves using data visualization techniques to represent the trends and patterns in COVID-19 data in a clear, concise, and visually appealing manner. And mainly, the project aims to help people understand the impact of the pandemic, track the progress of the disease, and make informed decisions based on the data driven insights. Visualizing COVID-19 data is an important way to track the pandemic and its impact on different regions and populations. Moving to the steps involved, these were the steps which were involved during the process of visualizing COVID-19. These were data collection, data cleaning and processing, data transformation, data visualization, and visualization of development. Moving to the data collection, here in this step, the data related to the COVID-19, such as daily case numbers, deaths, recoveries, and vaccination rates, is collected from reliable sources such as national or international health agencies, research institutions, or open data repositories. For example, the data can be collected from sources like World Health Organization (WHO), the Centers for Disease Control and Prevention (CDC), or the Johns Hopkins University COVID-19 dashboard. Here, I collected the data from the CSSC, that is Center for System Size Engineering Data Repository, and loaded into the Pandas data frame in Python. Here is the screenshot of the GitHub repository, which I will collected the data from this. And moving to the data cleaning and pre-processing, here the collected data which I was got is cleaned and pre-processed to remove any errors, inconsistencies, or missing values. And this may involve the data cleaning, data aggregation, data transformation, or data filtering. For example, data may be cleaned to correct any data entry errors, aggregated to a daily or weekly level, or filtered to include data from specific regions or time periods. This was the data which was collected and pre-processed. Coming to data transformation, the data is transformed to extract specific information and insights. For this project, we'll focus on daily confirmed cases, daily deaths, and daily vaccinations. This was from the Excel sheet. And coming to the data visualization, based on the project objectives and the data characteristics, appropriate visualization techniques are selected. For example, line charts which can be used to show the trend of daily COVID-19 cases over time. In coming to the bar charts, these can be used to compare the vaccination rates across different age groups or regions. and like same as the choropleth maps that can be used to show the distribution of COVID-19 cases or vaccination rates across different countries or states. And this data is visualized using various visualization techniques in Matplotlib and Seaborn, and some of the visualizations are created like line chart. And this chart shows a steep increase in the cases and deaths in the late 2020, followed by gradual decline in the early 2021. And coming to the bar chart, this chart shows a steady increase in the vaccination since January 2021. Coming to the heat map, a heat map is created to show the distribution of confirmed cases across different states in the US. Like this map shows the California, Texas, Florida have the highest number of cases. And moving to the visualization development, and here by using the data visualization tools or programming languages such as W, Power BI, Python or D3JS, the selected visualizations are developed. For example, a line chart can be created using a visualization tool called W by plotting the daily COVID-19 cases on the y-axis and the dates on x-axis. Like the customizing chart to include labels, legends and tooltips for additional information. Moving to data visualization using Python, here the data source can be collected from the COVID. I was collected the data source from the COVID-19 data repository by the Center for System Science and Engineering at Johns Hopkins University. Tools used in this project are the Python libraries like Pandas, Matplotlib and Visual Studio. Moving to the program and output, here alternatively we can also access the data directly from the CSSC GitHub repository using the links provided in the references. Time series data and daily reports data. Here each daily report contains data in the CSV files, CSV format. Like we can load these CSV files into a pandas data frame in Python to perform the data analysis and visualizations. Here's an example how to load these CSV files from the CSSC GitHub repository into the pandas data frame in Python. Let me show you the source code. Here's the source code. Yeah, here the first step is importing the necessary libraries like pandas, glove and matplotlib. And the next step is second step is specifying the directory where the daily reports are stored, like replacing the actual path to the directory. And the third is use the glob module to get a list of all the CSV files in the directory using the glob module. And we can concatenate the CSV files into a single data frame by using the array to li. And here we use a for loop. Here we use the for loop to iterate over all CSV files in the directory and read them into separate data frames. Then we use the concat method to concatenate the separate data frames into a single data frame. Once this data is loaded into the data frame, we can perform the data analysis and visualization using the Seaborn or various techniques in the pandas like matplotlib or other libraries. And here this will help us how to plot daily confirmed cases and deaths in the US over time using matplotlib. We'll run the code here. It will show the chart for us, x-axis and y-axis, where the dates were shown on the x-axis and number of confirmed cases on the y-axis. here. We'll see here the dates were on the x-axis from 2020 05 to 2023 05, which yeah, that's it. These were the number of cases on the y-axis. This was the chart. That's it. Let's back to the presentation. Yeah, here we that's it. That's the graph we got there. And in this code view, we first filter the data frame to include only data for the US and then convert the data column to a datetime format, and we group the date by date and aggregate the daily confirmed cases and deaths. Finally, we plot the data by using Matplotlib. Moving to the findings and insights, here the visualizations are analyzed to extract the meaningful insights from the data. Some possible findings and insights which were include: US experienced a significant surge in the COVID-19 cases and deaths in late 2020, which was followed by gradual decline in the early 2021. Also, US has been steadily increasing its vaccination rate since January 2021. And the other is California, Texas, Florida, which were the states with the highest number of COVID-19 cases that are. Sorry. Oh, yeah. Moving to the takeaways. Here, but overall, visualizing COVID-19 data is a powerful tool for understanding and communicating the impact of the pandemic, and it can help us to inform the decision making and raise awareness among different stakeholders. And visualizing COVID-19 data can help us understand the pandemic better, identify trends, and make informed decisions to mitigate its impact. Moving to the conclusion, here there are there are many data visualization tools available such as Tableau, Power BI, Python libraries like Matplotlib or Seaborn, and online platforms also like Flourish or Data Wrapper, which can help create visually appealing and informative visualizations of COVID-19 data. And mainly, it's important to ensure that the data used for visualization is accurate, reliable, and from reputable sources. And also, the visualizations which were designed to be accessible, informative, and understandable to a wide audience. And with the right data sources, tools, and design principles, we can create compelling and informative visualizations that communicate the urgency and complexity of the COVID 19 crisis. And note that the data may be updated frequently, so it is recommended to regularly check for the updates and download the latest version of the data. And moving to the references, that's it. I hope I finished it. Thank you.